We're going to go ahead and talk about variation today. Direct variation, inverse variation, or combination thereof. So if you think of a circle, we would say a circle varies directly to its radius because as the radius gets bigger of a circle, so does the circumference. Or if the radius of a circle gets smaller, the circumference gets smaller. So in general, we would say circumference is equal to k times r, where k is a constant of proportionality. All variation problems will have a k. Sometimes you'll know that, sometimes you'll have to figure that out. For this particular problem, our circle varies directly to the k value to be 2 pi times your radius. Direct variation means as one goes up, the other goes up, or as one goes down, the other goes down. In general, we would say y is equal to k times x. Once again, k is your constant of variation. This is a special line right here. Basically, it's a line whose y-intercept is 0. Any direct variation is a special line with a y-intercept of 0. Now suppose you consider driving from here to the Twin Cities. It's a set distance, but if you went ahead and decreased your rate, that would increase your time. Or if you increased your rate, increased your speed, that would decrease your time. So these are inversely related. Rate and time are inversely related because as one goes up, the other goes down. Inverse variation is actually a special rational function. It's a rational function in which your x and y axes are your vertical and horizontal asymptotes. Inverse variations are y is equal to your k, your constant of variation, divided by x. So in general, in solving variation problems, you want to write your general equation with the value of k and the variables they give you. Typically, you want to then plug in the information they give you so that you can find the value of k. You're going to then solve that or write your particular equation after you find the value of k. You're going to plug the value of k into your general equation. Then you're going to go ahead and answer the question that's being asked. Sometimes they want you to do something with it. Sometimes they just are looking for the particular equation. So here we have w varies directly as z, but inversely to the square root of z. So with that in mind, since w varies directly to z, we'll go w equals. We're always going to go and put in our constant of variation after the equal sign. Directly to z, that means z is going to be in the top. Inversely means that's going to be in the bottom, and it's the square root of u. So I'll put the square root of u in the bottom. This is my general equation. Now I'm going to go ahead and take this information, plug it in for z, u, and w. Now I can go ahead and solve this. I know the square root of 9 is 3, so it's really just a 2/3 k on the right. Then I can go ahead and get rid of that 2/3 by dividing by 2/3 or multiplying by the reciprocal of 3/2, and I get k to be 9. So now I want to take this value of k right here and plug it in right here, and this is referred to as my particular equation. Now, sometimes they'll give you other information in which they want you to find, say, w or z given certain things. But in this case, they didn't. So here we have y is directly proportional to x and inversely proportional to the sum of r and s. So we can go y equals, always throw in your constant of proportionality, is directly proportional to x. So that means x is in the top. Inversely means it's going to be in the bottom. Now, inversely to the sum of r and s. So r and s have to be in the bottom. Sum is your answer after you add. So that's my general equation. So now I'm going to come along, take x being 3, r being 5, S being 7, and Y being 2, put them in, and then I can work out what K is. So in the bottom I get 12 when I add those together. Then I can go ahead and solve this. I could either simplify this fraction or just multiply by 12, would not make a difference. Either way, I end up getting K to be 8. So now rewrite your general equation with K being 8. And this is referred to as our particular equation. Take a little bit of time to read through this, and then we'll work this out. So we have our volume is directly proportional to the moles in temperature, to their product. By the way, temperature is measured in Kelvin. And it's inversely to the pressure. So we're going to go volume equals, always throw in your constant of proportionality directly, so that means this stuff is going to be on top. We have product, that's your answer after you multiply. So it's the product of N and T. So it's N times T, because it says product, inversely to your pressure, so that means pressure is going to be in the bottom. So that's the first part. Now they want to know what happens to our volume when we do some changing of our moles, of our temperature, and our pressure. So we have our basic function right here, variation. We're going to go ahead and make some changes. We're going to have the value of K. The moles, it says, is doubled, so I'm going to replace N with 2N. It says the temperature and pressure are both reduced by half. So it's instead of T, it's half of T. Instead of P, it's half of P. So now I need to simplify this to see how it compares to what I started out with. Now, you could realize that you have 1/2 times the top, 1/2 times the bottom. They're going to cross out. So that leaves you then with this. You might be wondering, why is the 2 there? Well, it's really what we have up here is a K times a 2 times an N times a T. If everything's multiplication, you don't really need the parentheses. So then you can multiply in any order you want. I want the K, N, and T all together so I can see how it compares to my original. So if I look at this, it's really just 2 times what I started out with. So if it's 2 times what I started out with, then I just say my volume is doubled. So, a couple other questions. What would happen if our temperature was reduced by a factor of a third? Well, if it's reduced by a factor of a third, that means 1/3 of it's being eliminated, and we're only left with 2/3 of the temperature. So instead of putting T, I'm going to put 2/3 T. Now I'd want to compare this to my original. So I can pull that 2/3 in front. It's really 2/3 times my original, so I'd say my volume is 2/3 of the original. But how is that different than if the pressure is 1/3 of the original pressure? So I have my original, not doing anything to the moles and temperature, but my pressure is 1/3 the original. So it makes a difference in the phrasing, whether if you're reducing it by a factor of a third, meaning getting rid of a third, so you're left with 2/3, or if it's being 1/3 of the original pressure. So by the way, in this case, instead of dividing by a fraction, you multiply by the reciprocal. So it's 3 times the original, so your volume would be tripled.